Right, so in the previous video, we were going through how an AI algorithm parses the Times of Malta National news articles, and we saw at a high level the different clusters that are created by the AI algorithm. What we're going to do in this video is we're going to take a bit of a more of a deep dive into the actual words that make up the article and the relationship between them. So rather than viewing the article as a whole, like we did in the previous video, we're going to look at the words themselves and the relationships between them. So what we've done is, like I explained in the previous video, once you run the script, you'll have the two files generated, one of which is going to be this CIF file. Now this CIF file actually is a file which describes an undirected graph. You'll see what that means in a minute. And for every word that the machine learning algorithm encountered, it basically describes what the AI algorithm thinks are the most similar 10 words to that. So for example, for Malta, we have Sunday, Malta's revealed yesterday, reported group, contacted newspapers, reacting and routers, which the AI algorithm thinks is the most similar. Now, by the most similar, we mean these words tend to appear together in the same context, in the same sentence, in the same article. Intuitively, for example, this first relationship over here is the Sunday Times of Malta, and apparently they also say quite a bit. The Sunday Times of Malta revealed yesterday or reported that a group of, or the Sunday Times of Malta was contacted by, and so on. So similar to it, we've done the same for every single word and put it into a nice graph. Now, in order to see these graphs, you're actually going to need a free program which is normally used to analyze genomes or protein structures. However, we're going to use it for displaying graphs. So you can just download this from here, cytoscape. Once you download it, which should run on any platform, go ahead and open it. And once that opens, you're going to be displayed with this. First thing we're going to do is import our network from the file system. Let's see, so we had a CIF file. Let's open the only option that we have. Now this is quite, as you can imagine, this is quite a heavy graph, so it's going to be quite heavy on your machine. However, I've tried to keep the amount of information within the graph down to a minimum, though like you're seeing over here, it might take a while even on a pretty powerful PC. So once that loads, you're going to see a mass of blue, because right there, because the labels aren't, the words aren't too far spread out. However, I'm going to show you a couple of tricks that I use when I am analyzing this graph. So if you zoom out, you can just about see that there is a particular word over here connected to a mass of other words, to at least 10, as I explained before, by lines. Now, what we can do is take two approaches. Either focus on a particular word and see what the AI algorithms thinks we should also look at. So let's say, for example, we would like to know a bit more about Malta's Prime Minister. So what we're going to do is Dr. Muscat. So if we put in Muscat into the search term, this is going to go ahead and search the network, and as you can see, a single entry ended up over here, and it's been selected for us. So let's take a bit of a deeper look at this. Let's select this node. I am going to hide all the others just to make it a bit easier to navigate. So we're left with just one. And what we're going to do next is right click on it and use this diffuse functionality. So what this diffuse functionality does is, if you remember your primary school science, diffusion is when you like drop a dye into water and eventually, and you observe how from a concentrated spot it spreads out through the water. And this is exactly what we're doing over here. We're making muscat the center of our concentration of our diffusion, and we're seeing which nodes are closest, which other words are closest to muscat, so that we would be able to build what we call a subgraph. Now, as you can see down here, we have another 3 columns. The one that we're interested in is the diffusion output rank. And the diffusion output rank means how close a particular word is to muscat. Now we'd like to see, for example, the closest 100 words. So let's set the current rank to 100, tap set, and now we would like to create a subnet from the selected node. So let's create that. Let's show all the nodes and edges, and let's refresh our layout. Okay, so even without knowing anything about Malta, we'll start seeing a bit of a pattern. So muscat, if we right click and do select the first neighbors, is the prime minister, Castile. There is he's also in government, Labour Party, diplomat, and also he's connected to Delia and leader because he is the Labour Party leader. Let's have maybe a bit of a closer look. Let's say, for example, what is the actual relationship between muscat and Delia? Now, to a Maltese, this is very obvious, but maybe if you're exploring a domain which you are not familiar with, it's helpful to figure out what the paths that connect muscat to Delia are. So you can download an app within Cytoscape, which is the path linker, and its job is to show you the different paths between 2 nodes. Now our graph is undirected, and we're going to say, listen, the source is muscat, and the destination or the target is Delia. Show me the top 3 paths, and let's run it. Okay, so the algorithm shows us the sort of top best paths, and now we start getting a clearer picture of how muscat and Delia are actually related. So we see that muscat and Delia both are leaders, which is correct. And we see that actually muscat is connected to Labour, while Delia is connected to nationalist. So it's sort of directly telling you both of them are leaders. Muscat is leader of Labour, Delia is leader of nationalist. So you're already making connections between different entities, which for a newspaper or a Maltese, this is pretty obvious, but when you're exploring data which you don't know, these give valuable insights. So let's take another example. Let's go back to our original one, show all the nodes and edges, and let's say, for example, let's ask the newspaper, the AI algorithm, what property looks like in Malta, what the news about property is. So we're going to run the same algorithm. Now here you can't really see the node, so I'm going to do the same trick like before, which is to hide all the unselected nodes, and we're going to run the diffusion again. Let me get rid of the previous one, so I'm going to delete the previous columns that we had generated, and we're going to run the same diffusion algorithm. So while this runs, I'll also do a quick introduction to the next video. Right now we're already we already know the word that we would like to investigate. However, in the next video I would like to take a global approach to our investigation. You know, which words would be the most interesting, which words are where should I even start looking if I don't even know what kind of words to look for in this first place, like I'm doing over here, looking at the property. So in the meantime, the diffusion algorithm ran. We're going to do the same thing like before. We're going to see the top 100 related words, create a new subgraph, and we end up with something like this. So let's show all the nodes and edges again and refresh the layout. So if we look at it in this context, we can see that property, the closest words to it are these over here. So acquiring, there's Gaffarana, who is a property development. We see tenants and compensated, shady, which is a big problem in Malta, as any Maltese would know. What's interesting is connected to shady are those words like defamatory, implicated, losing credibility. And there's also a link between shady, as you can see, and compensated, close to tenants, which I saw over here. You see landlords, deprived, leases, terms, rental, etc. So keep in mind that the AI algorithm has no idea what these words actually mean, but it's automatically clustering them close to each other, so that when you are doing your research on a big body of text, you actually know what to look for. So let's apply the same trick that we've done before. Let's say, for example, what is the relationship between separation and property? So we'll go back to our path linker, select the right one, which is this in fact, and let's say separation is our source and property is our target. And if we submit, I seem to have chosen the wrong one. So because separation is misspelled, so let's do that again. Okay, so we see that separation, there seem to be a couple of paths towards separation, which is probably Gaffarana built some palazzo which has some matrimonial. One way of checking exactly what this is to go to our favorite search engine, Google, and do something like this, which is cite the Times of Malta.com, and put in the words that come up over here. So I have property, Gaffarana, palazzo, matrimonio. So property, palazzo, Gaffarena, Gaffarena, and matrimonial. And we'll see what were the actual articles that sort of came up here, and we'll see that yep, there is one which came up, and Gaffarana, there was some in the same article, there was a marriage and the palazzo. So it looks like they're only connected because they seem to have appeared within the same I don't know, article. We can't really see it because it's been taken down in the meantime, so I won't be able to show it to you Specifically, however, you can see that it's very easy to start maybe looking in directions which you hadn't thought about before using this particular method. Uh, and just like that, you can continue on doing um, other things as well. One of my favorites is seeing, for example, what's the attitude towards plastic in Malta. So let's do that. Let's go back to highlighting this and showing. So there's our plastic over there. You could just see it. Let's hide it again and apply our same diffusion trick. So let's do that. This time, however, I'll show you a way, a very useful feature of this program, which is to generate HTML graphs so that you can embed into a web page, and will also make it a bit more easy to figure out what's going on, because we'll apply different styles. So let's pause this. Right, so that ran, and we'll do the same trick like we've done before, which is show us the top 100 terms related to plastic in what is news, create a new subnetwork, and show me everything within this subnetwork. So let's refresh everything again. Okay, so again, it's actually pretty bang on the money, because plastic, packaging, rubbish, waste, beverages, pieces, carrier, and so on. Let's make this a bit more interesting, as I said before, by changing the style. What I like to do is changing the style to something like this, where we can now also play around a bit with let's make the font a bit bigger, shall we? 20. And what we're going to do is change the fill color of every node that you see here to have a relationship with the diffusion rank. So if we open here, column, I would like to diffusion output rank, and mapping type is going to be continuous mapping. So if this isn't so intuitive, let's change the mapping. Let's say go from yellow to red. Okay. Yes, I'm sure. So let's switch these around. The ones which are closer to our root term are going to be very dark. The ones that are farther away are going to be lighter colored. So that's what you can see over here. Let's change the label color because I can't see. There we go. So for example, plasticus here, you can see it's very red, and then another red one over here, which is pieces. So you get quite an interesting graph over here. So let's say, let's say you would like to present this to maybe a non-technical audience with your findings, right? What you can do is file, export, and export your network to a web page. Now, as it's saying over here, we've had hundreds of nodes, so what I would suggest is exporting just one particular network, one subnetwork, rather than everything. So we'll go into the network tab. This is the one that we're viewing right now, and we can export this one. Since I'm not going to be using any of the others, I'm just going to delete these. So we're left with just this one, and now I'll export it. So file, export, network to web page. Let's call it plastic.zip. And we're going to end up with plastic.zip right there. So let's extract it. So plastic. Extract here and web session. So now if we open a small web server, cd plastic, let's go into web session and start a web server. Okay, so we have a web server showing this all the data in web session. Let's visit localhost 8080 and 8000, and we end up with this being opened. So you can see these are the network that we just exported, and you can again play around with all the different things like we've done before. See, let's change the background. Before it was quite dark, so yeah, that would be something like that. That's pretty good. And now you end up with an interactive graph that you can show to your users. So that's a very interesting feature of Cytoscape. So in the next video now we're going to, rather than focus on one word, we're going to do an analysis of the whole graph. Stay tuned.